All right, so we've been working with triangles and parallelograms, and this is continuing our work with triangles. So sometimes, if you remember, for a triangle, it was supposed to be a nice triangle, or we had something like that. And then we could draw a vertical line down to the base from that vertex, and that would give us the height. And this was our base, and then we take 1/2 base times height. No problem. Sometimes we may have to adjust the picture to actually find what we need, okay? So sometimes in this case here, what we're gonna have to do is we're gonna have to extend the base to the right just below the vertex, then draw a vertical line from the base to that vertex. And the height of that's gonna be the altitude or the height. And so what happens is sometimes we have to extend our base out further, and I'm just gonna extend it further. And then we're going to extend that vertical line down here. So that's a 90-degree angle. And so this is going to be our height. This is still our base. And so now we have base times height there. And that's going to be what we used in our calculation of area equals 1/2 base times height. Now we can also use different legs or different sides for the base. And so maybe on this one, we'll say this is the base, and maybe on this one, we'll say this is the base. That way we have this one, we have this one, and we have this one. So how are we going to do that? Now this one, I might not have left enough room, but this is going to continue down. And then this is going to do that. And I can't draw those because I have a box that pops up here. So that's going to be that, and we'll still have this. Now this is going to be our height. That's our base, and we can still find the area. Now what about this one? Well, this one, guess what? We're back to that original triangle. This is our vertex, and so we have a 90-degree, and so that's our height. That's our base here, and we can take 1/2 base times height and get that. Okay, so we can have a base be any of the sides depending on how we want to draw that base out and extend it and get our height out. Okay, so it works in any of those fashions. All right, so now what they've done is they're going to give us some triangles, and they've done the extension here like this, and then they give you the height. And so all we are really doing here is, again, multiplying. So area is equal to 1/2 the base, which is 14, and let's write that as 14 over 1, times our height, which is 9 over 1. Okay, well now we can cancel, and the 2 will go into 14 7 times. And so what does that leave us? Well, that leaves us with 7 times 9, or 63 all over. Oh, we forgot to write that as a 1. 1 times 1 times 1, which is 1. And then we have feet, so it's going to be feet squared. All right, what about this one? Well, here area is equal to 1/2 the base, which is now 8 centimeters, so 8 over 1, times the height, which is now 6 centimeters, which is 6 over 1. Now this time, we can take that 2 and divide it into the 8, or we can take that 2 and divide it into the 6 and get 3. So it depends on how you want to do it. It really doesn't matter. So if we take it into 8, we'll have 4, and this is a 1. And so then all we have to do is take 4 times 6, and we get 24, and this is centimeters squared. And so that would be our area there and our area there. What about this one? This is one that kind of flipped upside down. If we just kind of turned this around and put that there, then the base would be down here at the bottom, kind of like we're used to. But this still works, remember. And so area is equal to 1/2. Now our base is 12, so it's 12 over 1, times our height, which is 5 over 1. All right, well, we can still cancel. 2 goes in here once, 2 goes in here 6 times. Well, now our denominator is just 1, and we have 6 times 5, which is 30, and then we have inches squared. And so that is the area of this triangle in this format here, using that base and that height. And again, we could have drawn out this and had that height and that base, but they didn't give us those values, and so we couldn't use it. Or we could have gone out this way and used that height and this base. So there's a lot of things we could do, but with what we're given, that's how we would solve this one. All right. So your weight on the moon. So on the moon, you would weigh only 1/6 of what you weigh on the Earth. If you weigh 150 pounds on Earth, what would you weigh on the moon? Well, what we're saying is we're taking 1/6 of 150. Now, if we remember our words, what does of mean? Well, of is equal to multiply. Okay, so what we're doing is we're taking 1/6 times 150. Now, since we're doing fractions, let's put it over 1, and we have that. Okay. Now, does 60 go into 150? Well, 6 go into 150. I don't know. Let's try 150, or we might have to have a fraction. So 6 goes in here twice. That's 12. That's 3. Bring down our 0. 6 times 5 is 30. And so this is actually just 25 pounds. And so that is how much you would weigh on the moon compared to what you weighed on Earth. Okay. And that's all I have for this section.